when saturation region is there. That means both junction, base to collector and base to emitter, both junction is in forward bias. It act as a closed switch and it carry a large current. Okay, so in short form, a summary of this: when transistor on, that means it is in saturation region and large current flowing through it. VC saturation. And when transistor off, IC is equals to 0, that means no current flowing through this, and VC is equals to VCC, VC is equals to VCC. So this is a summary. Okay, so here both junction is in forward bias and here both junction is in reverse bias. Are you getting this? Next, waveform. So this is input waveform, this is a C configuration and this is output waveform. So transistor act as a switch when both junction is in forward bias and it conduct. When both junction is in reverse bias, it does not conduct. When both junction is in forward bias, it conduct. When both junction is in reverse bias, it does not conduct. And we are getting output across the load. Okay, so in this way transistor can be on off by operating is in cutoff region and saturation region. If it is in cutoff region, what happen? It act as a open switch, and if it is in saturation region, it act as a closed switch. In this way we can control or we can act this transistor as a switch. If you want to on the transistor or if you want on the supply, it activate in saturation region. If you want to off the supply, transistor act in cutoff region. So as like a conventional switch, it can be on off the supply. So that's why transistor may act as a switch. In power electronic circuitry, transistor as a switch is very popular switch. Why? Because in power electronics application, such conventional switch are not used. Why? Because rating of such switch and size of such switch is larger and size of transistor is smaller than our conventional switch. So that's why transistor switch is most popular in electronic circuitry, because electronic circuitry are compact in size. As electronic circuitry, for example mobile, compact in size, number of ICs and number of memory cell, number of ROM, such part are introduced in a small compact size. So such electronics, complex electronics or IC oriented circuitry require small size, and transistor has small size compared with our conventional switch. So that's why in power electronics or in electronics or in advanced electronic circuitry, transistor act as a switch. Are you getting this? Next, application of transistor as a switch. Application of transistor as a switch. So first application in the logic circuit. In logic circuit, you know that AND gate, OR gate, XOR gate, XNOR gate, NOT gate, NAND gate, NOR gate. You know that? You doesn't know. See here, logic gate, I think there will be one subject for, I think, in third semester, DT, digital electronics. In that subject, that logic circuit part is introduced. Logic circuit. For electrical E4K, subject name is DEM, digital electronics and microcontroller. And for other branch, like electronics and telecommunication, IT, computer, AI, has one subject DT. I think DT, digital technique. So it has number of logic gates, AND gate, OR gate, NOR gate, XOR gate. So in that circuitry, transistor will be used. Okay. Then temperature control. If you want to control the temperature of geyser, cooler, AC, refrigerator, so then that application we can use transistor as a switch. Sensor with temperature controller. That means if you want to increase the temperature, then we can use the temperature controller. But for on-off application, we use transistor as a switch. The next, chopper circuitry. Chopper, it is a circuit in which we are converting DC into DC. So fixed DC to variable DC. Chopper is a circuit in which we are converting DC into DC. For that application also we use transistor. Okay. Chopper used for DC motor control. Speed control of DC motor by using chopper can be operated or on off by using transistor. Then multi vibrator and schematic trigger. So this is a wave shaping circuit, special logic circuit. It required transistor logic, transistor TTL logic.